Then so today we are going to discuss about the spanning tree protocol, that is STP. So STP is stand for spanning tree protocol. Okay. So anyone having the idea what is the spanning tree protocol?
No idea.
Loop prevention technology. When a
Mm-hmm.
broadcast stop find in generated in the network, then spanning is used to prevent the storm. So avoiding loops in the network.
Providing loop on the
No,
network, you mean to say that?
avoid loop. Avoid.
Okay, avoiding the loop on the network. Yeah, that seems correct. Means spanning tree protocol is nothing but is layer 2 protocol which is going to avoid loop on the layer 2 network. Means this is completely STP is completely dedicated protocol for the layer 2 technology. When we are saying as a layer 2 technology, it means we are discussing about the switching. Okay. So it is a layer 2. Let me just write some of the definition here. STP is layer 2 protocol. It is going to avoid layer 2 loop on the network. Means STP is a layer 2 protocol which is going to avoid the layer 2 loop on the network. How? By blocking redundancy links. Means if we have this switch, right? And we have this switch, correct? This is the cable is connected here. One cable is connected here. For example, 0/1, 0/1 this side, 0/2 this side, and 0/2 this side, right? Means if any traffic is coming here, might be chance it will go and loop here, right? Like that. And again it will come here and go like that, right? If it is happening very frequent, means if any packet or frame is going and like creating a loop like that, very frequent. So this frequent loop we are calling as a broadcast storm. Broadcast storm. Storm, you know, right? Means it's a lot of frames are exchanging to each other very frequently, and then in that case what will happen if broadcast storm is happening, then your CPU utilization will be went very high. And as this MAC address might be the different MAC address and multiple MAC address is learning, so your memory also will be high. Okay. So one case, if very bad broadcast storm or very frequent loop is happening on the network, in that case, might your switch can reboot itself. Means it's unable to handle this kind of traffic which is happening, which is unnecessary, which is happening. To due to that, might be your CPU utilization went 100% high. Your performance, switch performance will reduce. You know, it will reduce, and might be end user start facing the problem. Could be the case your switch can be reboot itself. Rebooting means it will take 10 to 20 minutes to make them switch up, and again it will start working. So whatever devices will connected on these switches will down, right? To stop this, we have a solution known as spanning tree protocol. So as a statement, you can see HTTP is layer 2 protocol, which is going to avoid layer 2 loop on the network by blocking redundancy link. Means, as I said, we have a two link, right? So what HTTP will do, it is connected like that. What HTTP will do, it will block one redundancy link. Means redundancy means is nothing but you have a two-way to reach your destination. Simple. For example, you are going from destination A to B, you have a two-way. If something, some flood or something is came and might be this road or something got damaged or something, then you have other way to go on the destination B. Means you have once we have more than one path to send any traffic or something. In that case, that scenario you can say we are saying as a redundant scenario, means we have a redundancy, or sometime we are calling as a term of high availability, highly
Yes, I
available, right? Means if we have
yes.
a three path, for example, so we have a three path, so it's a high available. Means one will something went wrong, it will down, then second path is available, then third path, might be fourth path are available, right? So we have a highly available route, you can say. So as soon if you have multiple switch, so multiple interface will be blocked. As one is working perfectly, then other three will be blocking state. Okay. So there is no traffic will be flow. I will coming and state how it's going on, and I will explain what the state, and in each and every state what it will do. So I will explain everything, but one path is okay, then traffic will flow by default from this path only. Those path will be blocked. Why it will block? Because to avoid layer 2 loop on the network. You got it?
Yes, it's clear.
Clear? Okay, great. Okay. Again, process of HTTP. What is the process? How it work? Okay, let's discuss bit from here. First, there are three processes. You can write here as well if you want. There are three process of spanning tree. And what I explained is the blocking and everything, right? It is happening automatically. We no need to do anything. Give me a moment. I'm getting a call. Okay. So there is three, process which performed by the spanning tree. First, all the switches will find the root switch. All the switches will find the root switch. by exchanging the BPDU message. Okay, I will explain in a moment. First, all the switches in the network will find the root switch by exchanging the BPDU message. Message every 2 seconds. Okay. Then second step, I will explain what is mean by this. So don't worry about all the non-root switch will find the root port RP root port to reach the root switch. Then third step, and also and all non all the switches will find the DP designated port. For each LAN segment. Okay, let's discuss what is mean by this. Okay, then process of switching. Sorry, process of spanning tree. Just highlight. Okay. Let me know if any confusion. So I will repeat the things again because it's very, very important.
Okay.
No? Okay. So we have switch 1, switch 2, and switch 3, right? Switch 1 having this is priority. This is priority. So by default priority is 32,768. 32,768. Okay, keep remember, I will explain what it mean. Okay, we have switch 1, switch 2, switch 3. Each and every switch having redundancy. Agree? If something path, this path will down, then traffic will flow like that, right? So
Yes.
means
Yes.
redundancy.
Clear.
Okay, perfect. So first statement, all the switches will find the root switch by the exchanging BPDU message every 2 seconds. Means once your network up, your cable is connected and it's up, right? So each and every switch will exchange BPDU, BPDU, okay, message to each other Here as well, they will exchange the BPDU. They will also exchange the BPDU, right? BPDU is nothing but Bridge Protocol Data Unit. Means it's kind of a message. I will explain what are the information will be inside and all those. Just understand the full form is BPDU, Bridge Protocol Data Unit. It's a like list of information will keep inside the BPDU message or packet, you can say. Okay, so packet will exchange between the switches and they will find the root switch. Root switch, I will explain in a moment what is switch, how it's electing and so on. But just understand as of now, a BPDU message exchange between the switch every 2 seconds and they find the root switch. Root switch means superior switch. Okay, as of now. Superior switch they will find in the network, and then after that they will stop claiming like I'm a root. For example, all the switch initially will claim like I am the root switch, because each and every switch will understand before. For example, you are only in the exam hall, for example, in your class, then what you will say, whatever number you will get, you will be first. Either you will get the 33 only, right? But if you have a multiple people in the class, okay, so they will claim, then like kind of fight will happen, and after that, who have a best number, that person will become a superior, right? So same thing is happening here. So number how number is playing the role, I will explain in a moment. Just
So
understand a
it's like
number.
an
Hmm.
it's like an election, right?
Yeah,
Between the
election.
switches.
Yeah, election. They're sending, exchanging the information, and building inside the election, and they will find like who is going to win on what basis of parameter. I will explain in a moment. Okay, then they will find a root switch. That is mean by first statement. Okay, then second statement is all the non-root switches. For example, just take example. If this switch become a root, right? Then these switches will be non-root switch, right? Non-root. Non-root, right? So one will be root and other switches will be non-root switches. Okay, clear? So all the non-root switches will find the best way to reach the root switch. So which port they are reaching to root switch, that port will become a root port. Okay, what will become root port, or generally we are calling as a RP, DP. Okay, that's the root port. And third is, and all the switches will find the DP port, that is the designated port. Okay, means all the switches, this one, this one, this one will find the DP port. So by default, root port having all the port as a DP port by default. Okay, and this switches for between this one, because it's already set as a RP, so cannot be DP. So between this LAN segment, because LAN segment we already set, each and every LAN segment I said, each LAN segment, this is a LAN segment, this is a LAN segment, this is LAN segment. Is this LAN segment, DP is decided. This LAN segment, this DP is decided. This one is pending. For example, due to some parameter, we need to find it out. What is the DP port? So for example, this will become a DP port. So each LAN segment, we need to find the DP port. Okay. So what is the RP? What is the DP? How root? Don't worry. I will clear each and everything. Just I'm explaining what I wrote here.
I just have one question. How that port would become DP port, like
Yeah,
the S3
definitely.
switch
Yeah,
or
that
the S3 switch?
as I said, I will answer all the query in moment. Allow me a moment. Just I was explaining what I wrote here. For example, point number 1, point number 2, and point number 3. What I wrote, I just explained. Don't consider about the RP, what is RP, what is DP, what is root. Just remember the things like some term is there which known as a root, some term as a DP, some term as a RP. Don't worry, I will explain. I will go more dive deep in a spanning tree because a lot of question will ask from the interviewer. So I will explain each and everything. Don't worry about that. You will be after completing. It will take 2 week minimum. After completing all those things, you will be expert in this spanning tree. Don't worry. Okay. So that I was explaining what is the term what I wrote here. Okay. Now I am going to explain first root. Right? We have root here, right? I will explain what is the root. Okay. So give me a moment. Let me select this one. This root switch. Okay. A root switch. Lower like that. The lower bridge ID. Switch will become a root switch. Well, lower bridge ID will become a root switch, and bridge ID consists of 2 bytes of priority and 6 bytes of MAC address. So by default priority is 32,768. Okay. So a lower bridge ID switch will become a root switch. Means, and bridge ID might be bridge ID confusing one. So bridge ID is nothing but it consists of 2 parameter. Means one is by default priority and second is a 6 byte of MAC address. For example, if any switch, for example, switch number one, bridge ID will be, for example, 32,768 plus, for example, take example as a 0 MAC address. So this is the number, this is the value is known as a root bridge ID. So once root bridge ID is each and every switch will consist a root bridge and they will exchange to each other and understand like who have a lower bridge ID. If you have any of the switch having lower bridge ID, in that case, that switch will become a root switch. And root switch is responsible to generate the BPDU. Okay, 1 second. BPDU. First, initially, all the switch will generate the BPDU and exchange to each other to find the root bridge. But once root is elected, in that case, all other switch will stop sending the root bridge because initially they are all the switches making their self as a root switch. That's what they are sending the BPDU. But now root switch is elected on the basis of, you can see here, and After that, root bridge only will send the BPDU message to lower switches. Whatever non-root switches are there, they will send. And once they will receive this BPDU, they will send to other switches, other connected switches. Okay. So how root bridge is going to be elect? All the switches will find the root switches by exchanging the BPDU message. So once BPDU message exchange, they will find like who have a lower root bridge ID, and that switch will become a root switch. That switch will become a root switch. Once root is elected,
Root.
yeah, root switch, root or root bridge or root switch, whatever you want, you can say. Okay, once is elected, then it will only send the BPDU message. So what is the root switch? Root switch is responsible to generate the BPDU message, and the lower root bridge ID, the lower bridge ID or root bridge ID, whatever you want, you can say, switch will become a root switch, and root bridge ID is consist of 2 byte of priority and 6 byte of MAC address. Okay, that is one statement. And so by default priority is 32,768. Okay, keep remember, sometime it's asking what is the by default root priority. If priority get matched, in that case lower MAC address will become a root. Okay, as I said, all the switches having the 32,768, 32,768, 32,768, that is nothing but is the default priority. Okay, if default priority is 32,768, so it's try breaker, right? So all the switches will match their MAC address. For example, 0A, G have 0B, G have 0C, right? In that case, this is a lower, then that switch will become a root switch. You got it? You have any confusion in root switch?
It's clear. No confusion.
Okay. Yeah, I will once we will do the lab and all those things. It will be very, very, very clear. Let me stop the recording. I will ask question if you have any, or